All right, we've made it to the last lecture for test 1. So we're going to look at solving polynomial equations by factoring and then some applications that we can use. So first, if we're going to solve a polynomial equation by factoring, we need a method to do that, and that method is going to be called the zero factor property. And the zero factor property basically says for any real numbers a and b, if a times b equals to 0, then either a must equal to 0 or b must equal to 0. And that property also holds true for 3 or more factors, not just 2. So when we want to solve a polynomial equation by factoring, the first thing we want to do is write the equation in standard form so that one side of the equation is 0. So that's going to normally look like ax squared plus bx plus c equals 0. Then we're going to factor the polynomial completely. And of course, what we have to do to factor the polynomial will depend on what we're given. Then we're going to set each factor that is containing a variable equal to 0, and then solve the resulting equations. And then the last thing is to check each of the solutions in the original equation to make sure that they work. So let's look at this first problem. For this one, we actually get to start at step number 3, because what I have here is one factor times a second factor equals 0. So we don't have to factor it out first. It's already in its factored form. So we're going to start with step 3 and set each one of those two factors equal to 0. And remember what we just talked about. Factors are two things that are being multiplied together. So the first factor here is the x plus 2. So we're going to set that equal to 0. And the second factor is x minus 6. And we're going to set that equal to 0. And then we're just going to solve each one of those equations for the variable. So for number 1, we would need to subtract 2 from both sides, and we get x equals negative 2. And for the second one, we would need to add 6 to both sides, and we get x equal to 6. So then to check, our original equation is x plus 2, x minus 6 equals to 0. And we have two possibilities. So first, we'll substitute negative 2 for the x's, and we want to see if that's true. So negative 2 plus 2 gives me 0. Negative 2 minus 6 is negative 8. And 0 times negative 8 is 0. And the equation 0 equals 0 is true. So that means that x equals negative 2 does work as a solution. So if we check x equals to 6, this time we will replace the x in the original equation with a 6. So this time we're going to get 8 times 0 equals 0. And of course 8 times 0 is indeed 0. So we get a true statement again, 0 equals 0. So what that means is my two solutions are x equal to -2, x equal to 6. Those are the two solutions to our equation. So if we look at the second problem, it's kind of similar. We already have this into its factors, something times something else equals to 0. So this time the first factor is x and the second factor is x minus 3. So we're going to start with step 3 again and set each one of those factors equal to 0. So the first one this time, of course, that's finished. There's nothing to solve. It already says x equals 0. And for the second one, we're going to add 3 to both sides. And I get x equal to 3. So we can check those. The original is x times x minus 3 equals 0. So if I check x equal to 0, we would substitute 0 for each one of those x's. This is 0 times -3. And 0 times anything is 0. So that gave me a true statement. And if I substitute 3 for each one of the x's in the original equation, we get 3 times 0 equals 0, or 0 equals 0 again. So both of those worked. So my two solutions are x equal to 0, x equal to 3. All right, for the third one, we're going to have to go back to the step 1 instead of starting at 3. Notice I don't have one factor times another this time. I've got a trinomial, 3 different terms. So they are in that standard form, ax squared plus bx plus c equals 0. So what we need to do is factor. So this is a trinomial. A is equal to 1. So you remember for these, all we had to do was determine that c is -12. And then we're going to list the factors of -12. So we could have 1 times -12, -1 times 12. We could have 2 times -6, -2 times 6. We could have 3 times -4, -3 times 4. And I think after that they would start to repeat. And then we need for b to equal -4. So we want the pair of factors that we just found that will add to -4. So that's going to be this pair. The 2 plus -6 will give me -4. So now we can use those factors to factor our trinomial. When a is 1, we know that the only thing that can multiply to x squared is x times x. And we just determined that the factors we need to use are +2 and -6. So now you see this problem looks just like problem 1 that we did. So we're ready to set each one of the factors equal to 0. And then we're going to solve each one. And of course, we get that the two solutions are x equal to -2 and x equal to 6. I'm not going to show the check for that one because it actually works exactly like the first one. So those two should work. All right, for number 4, this one adds one more step. I have a trinomial, but you notice first off the bat that the equation is not equal to 0. The only property we have for solving polynomials by factoring is called the zero factor property. So the only thing the equation can be equal to is 0. So if it's not, that's always our first step, is to rearrange or manipulate the equation so that the equation is equal to 0. Now this one is a trinomial where a is not equal to 1. So that means that we're going to look at using the AC method. And here a is 8 and c is 5. So 5 times 8 is 40. So we're going to list the factors of 40. So I have 1 times 40, 2 times 20. 40 is not evenly divisible by 3. We could do 4 times 10. We have 5 times 8. And I think after that they would start repeating again. So we need b equals 13. So the only pair of factors in the list we made that will add to 13 are the 5 and the 8. So remember with this one, when the a is not 1, this is where we have to rewrite the middle term. So we're going to write 13x as 5x plus 8x. Then we have to do factor by grouping. So my first pair, we have a common factor of x, which leaves me with 8x plus 5. And in the second pair, the only common factor is 1. So I'm going to write that as 1 times 8x plus 5. Then we have our common binomial factor 8x plus 5, which if we removed leaves me with x plus 1. And now we're finally to the point where we can solve. So we're going to set each one of those factors equal to 0 and solve each one of them. So the first one we need to subtract 5. I apologize, I'm running us out of space. But if we divide both sides by 8, I get x equals -5/8. And then for the x plus 1 equals 0, we just need to subtract 1 from each side, and we get x equals -1. So my solutions for this equation are x equal to -5/8 and x equals to -1. Now, if you want to check these, and it's always a good idea to do this because we're going to start running into situations before long where we actually have to check, because sometimes the solutions will be what we call extraneous. The easiest thing to do is use your calculator rather than write all of it out. you can pick up your calculator, go back to the original equation, and type it in exactly the way it looks by substituting your number for x, and you should be able to get the two sides equal. If you have trouble with that, you're welcome to send me an email and let me know, and we can look over that together. All right, for number 5, again, the first thing is I'm not equal to 0, and that is something that has to happen. So we're going to manipulate the equation first by subtracting the 12a so that we're equal to 0. So I don't have a trinomial this time. I have a binomial, and it's not going to be a perfect square or a difference or sum of cubes. So looks like the best I can do is to determine greatest common factor. And I think the greatest common factor here would be 4a. And that will leave me with a minus 3. And now this one looks really similar to problem number 2. So my first factor is 4a. I'm going to set that equal to 0. And my second factor is a minus 3. I'll set that equal to 0. And we're just going to solve each one. So I'm going to divide both sides by 4. Then for this one, we need to add 3 to both sides. So I get the two solutions, a equals 0, a equal to 3. So if you look really quickly up at the original 4a squared minus 12a, you pretty much do that one in your head if you want to check. If I substitute 0 for the a, we'd have 4 times 0 squared, which is 0. And 12 times 0 is 0, so 0 equals 0. And then just do the same thing with the 3, and you'll see that those are correct solutions. All right, one more of these. This one, again, first thing we have to do is manipulate to get the equation equal to 0. So let's subtract the 9 from both sides. So we get m squared minus 9 equals 0. So this one, hopefully you're starting to recognize as a difference of perfect squares. So that means we can factor this as m minus 3, m plus 3. If you don't remember why that's true, look back at your previous notes or contact me and let's talk about it. Now I have my two factors being multiplied equal to 0. So I'm just going to set each one of those factors equal to 0. And then solve each one. So we get m is equal to 3. Or m is equal to negative 3. So our two solutions, m equals 3. M equals to negative 3.